National University Sudan, Faculty of Graduate Studies, Administrative Science. Good morning, my students. Welcome to our second lecture in Business Statistics. In today's lecture, we will study one of the most important foundations in statistics, how to organize raw data into a meaningful form. When researchers collect data from questionnaires, surveys, experiments, or company records, the data usually appear as a long list of numbers. Looking at hundreds or thousands of observations makes it difficult to understand what the data are telling us. Therefore, statisticians organize the data before beginning any analysis. Today we will learn what data organization means, how to construct a frequency distribution table, how to calculate class intervals, how to determine frequencies, how to calculate relative frequency, how to calculate cumulative frequency. Finally, how to present the data using a histogram. By the end of this lecture, you should be able to organize any set of raw numerical data into a professional statistical table. Let me start by what is data organization. Before performing any statistical analysis, the first step always organizing the data. Data organization means arranging raw data into a logical and systematic format so that it becomes easier to understand and interpret. Imagine you conducted a survey among 200 customers. The response may look like this: 25, 41, 18, 30, 22, 45, 33, 19, and so on. Looking at these numbers alone tell us very little. However, after organizing them into groups, patterns become much clearer. For example, we can immediately identify which values occur most frequently, whether most observations are high or low. So, whether the data are spread out or concentrated. Data organization transforms a confusing list of numbers into useful information. Today's example contains the following raw data: 0, 7, 30, 35, up to 39. The first step is arranging the observation in ascending order. So here we rearrange the raw data. The data appeared in example 2.1. We rearrange ascendingly from the smallest to the largest. So we started from 0, and whenever the numbers are repeated, we have to write it as it is. So we have, this is a new form of the data after we arrange it. So the first step is rearranging the observations in ascending number order. This arranged list is called an array. So this is called an array. Notice that arranging the data does not change the values. It only makes them easier to work with. Step 3. Determine the number of classes. Once the data have been arranged, we need to divide them into groups called classes. The question is, each class represents a range of values, but the question is, how many classes should we create? If we create 2 view classes, important information may be hidden. If we create too many classes, the table becomes unnecessarily complicated. One commonly used guidelines is Sturge's formula. This is the Sturge's formula. Here it is small k, and small k stands for the number of classes, and the Sturge formula says small k, or the number of classes, should be equal to 1 plus 3.322 log 10 and the number of values. So we displayed the formula now. N, where N represents the number of observations, small k represents the recommended number of classes. The formula gives only an approximate answer. We usually round the result to the nearest whole number. This ensures that our frequency table remains easy to read. So in this example too, the number of classes should be equal to small k equal 1 plus 3.322 log 10, and the number of values are 20. So small k equal 5.322, and the number of classes could be 5 or 6, no problem. It could be 5 classes or 6 classes. So now let us apply the formula to our example. So in this data set, the number of observations is 25. It is 25. So after substituting into Sturge formula, we obtain approximately 5.64 classes. Since we cannot have a fraction of a class, we round the answer. Therefore, our frequency distribution will contain 6 classes. Always remember, Sturge formula is only a guideline. Depending on the situation, statisticians may use 5, 6, 7, or even 10 classes. The objective is to summarize the data clearly. Calculate the class width. Now that we know we need 6 classes, our next task is determining the width of each class. The formula is straightforward. Class width equal range divided by number of classes. The range is simply the maximum value minus the minimum value. For our example to 1, the maximum value is 39 and the minimum value is 0. Therefore, the range equals 39. Dividing the range by 6 gives 6.5. Since class widths are usually whole numbers, we round it to choosing a class width that is easy to use. Makes the table much more simpler. So we are going to use 7. Look here. We find the class width by dividing the range by the number of classes, and our range equal 39 minus 0 equal 39. Okay. Now we can construct the class intervals. We begin with the smallest observation, which is 0. The first class becomes 0 to 6. And the second class starts immediately afterward, 7 to 13, then 14 to 20, 21 to 27, 28 to 34, and finally 35 to 41. Notice that every observation belongs to one and only one class. There are no overlaps. There are no gaps. This is extremely important because every data value must fit into exactly one class. It will be like this, ya shabab. Class intervals. So from 0 to 6, from 7 to 13, from 14 to 20, and so on. What we observe that the interval here from 0 to 7 is 7, from 6 to 13 is 7 also. And from 0 to 6, counted by your hand, 0, 1, 2, 3, 4, 5, and 6. These are 7. Don't fall in the same mistakes that previous students fall in. They think that 7, it should be 0 to 7. No, it is 0 to 6 because the 0 is included in the computation and the 6 is included in the computation. Now comes the counting stage. For every class interval, we count how many observations fall inside it. The number is called frequency here. This is frequency. Okay. For example, the first interval from 0 to 6 contains 6 observations. Therefore, its frequency equals 6. Continue counting every interval until all observations have been included. Also notice 2 new terms. The first number in each class is called the lower class limit. These 0, 7, 14, 21, 28, and 34. The last one is 34. Up to, it is like this, up to 41. This is 41, 34, 41. These are called lower limits and these are called upper class limits. These limits define the boundaries of each class. The total of all frequencies should always be the number of observations. So, equal to the total number of observations. This is an important way to check your calculations. Class boundaries. Next, we discuss class boundaries. Students often confuse class limits with class boundaries. Class limits are the numbers we write in the table. For example, 0 to 6. However, the actual measurements may include decimal values. Therefore, we define class boundaries. To calculate class boundaries, we subtract 0.5 from the lower limit and add 0.5 to the upper limit. For example, 0 to 6 becomes minus 0.5 to 6.5. This is here is minus 0.5. Similarly, 7 to 13 becomes 6.5 to 13.5. Notice that adjacent class is now touched perfectly. This eliminates any gaps between intervals. Class boundaries are especially useful when constructing histograms. Class midpoints. Another useful quantity is the class midpoint. The midpoint represents the center of a class. It is calculating by averaging the lower and upper class limit. Look here, 0 plus 6 divided by 2, it is 3. 7 plus 13 divided by 2, it is 10. 14 plus 20 divided by 2, it is 17. 21 plus 27 divided by 2, it is 24 up to the end. Midpoints are commonly used when estimating the mean from group data. Let us come to relative frequencies. Relative frequency tells us the number of observations. Relative frequency tells us the proportion of observations. The formula is frequency divided by total number of frequencies or observations. Suppose one class has frequency 6 and there are 25 observations altogether. The relative frequency becomes 6 divided by 25, which equals to 0.24 or 24%. Also, if the frequency is 8 and the total frequencies are 25, we divide 8 by 25 and the relative frequency is 0.32 or 32%, and so on up to the end. Relative frequencies allow us to compare classes using percentage. This is especially useful when comparing different data sets with different sample size. Cumulative frequency. Now we calculate cumulative frequency. Cumulative means running total. The first cumulative frequency equals the first frequency. The second cumulative frequency equals the first plus the second. The third equals the previous cumulative frequency plus the next frequency. Like this, we have the first frequency is 6, so the first cumulative is 6. The second frequency is 8. We add up 6 to 8, so we'll end up with 14. Then we add 14 to 4 plus 4 plus 14, it is 18. Then 18 plus 2, it is 20. Then 20 plus 2, 22. Then 3 plus 22, and it is 25. You must observe that the last cumulative is equal to the summation of frequencies. So the final cumulative frequency must equal the total number of observations. Cumulative frequencies help answer questions like how many observations are less than 20? How many students score below 60? This concept is widely used in statistics. Let us come to histogram. Once the frequency table has been completed, we can display the data graphically using a histogram. A histogram is a graph used for continuous numerical data, unlike bar charts. The bars in a histogram touch each other. Why? Because the class intervals are continuous. The horizontal axis displays the class intervals. The vertical axis displays the frequencies. The taller the bar, the more observations belong to that class. Histograms help us quickly understand the shape of the distribution. For example, we can identify whether the data are symmetric, positively skewed, negatively skewed, or approximately normal. How to construct the histogram? Let us use the frequency table shown here. Each class interval has corresponding frequency. To construct the histogram, first draw the horizontal axis and label it with the class boundaries. This one. This is the horizontal axis, the class interval or class boundaries. Next, draw the vertical axis and label it with the frequencies. It's like this. Okay? For each class, draw a rectangle. The width represents the class interval. The height represents the frequency. Remember, the bars touch each other because continuous data have no gaps. This graphical representation provides a quick visual summary of the data. Today, we learned the meaning of data organization, how to construct a frequency distribution table, how to determine the number of classes using Sturge's formula, how to calculate class width, how to create class intervals, how to calculate frequencies, how to determine class boundaries, how to calculate class midpoints, how to calculate relative frequencies, how to calculate cumulative frequencies, how to construct and interpret a histogram. These concepts form the foundation for many statistical techniques that we will study later, including measures of central tendency, dispersion, probability distribution, and statistical inference. Thank you for attention, and we will meet in lecture 3.